I'm Rob Cotton with PepsiCo Frito-Lay. This is my first time attending the BEMA convention, and what I like most about the baking industry is eating baked snacks.
Hi everybody, it's really a pleasure to be here. This is the first time I'm attending this conference, and I've been super amazed about the fact that it is a family affair and that families come as well, because A, that's a unique situation, but across our industry, this is, I always say, like at least on the packaging side, it's the biggest small industry in the world, and it's a lot of entrepreneurs and individual private family companies, and so it's a really a great family experience. I always enjoy meeting our owners all over the world. I'm going to talk about RCBR, so what that stands for is recyclable, compostable, biodegradable, or reusable. That came out of the Ellen MacArthur Foundation commitments that many of the big brands signed up for. And that timing was we were going to do all these things by 2025. Well, that's tomorrow. And so now where are we at? And we're going to talk a little bit about what we're doing in this space and really kind of challenge you a little bit on some things that we're moving on towards the future of what's happening in the industry and what's next, perhaps. So I'll tell you a little bit about snack food structures. We bake snacks in vertical form fill seal would be very similar. We're going to talk about recycling and what's happening in that space and where we see flexible packaging fitting in recycling. And then I'll spend quite a bit of time talking about what we're doing to reinvent the packaging space with biodegradable packaging, and then maybe a call to action for everybody here. So we'll start with a little bit about our structures, and it's basically 2 layers of polypropylene films that are glued together. The barrier properties we get from metallization, and the metallization layer is not foil, it's metallized film, and the fun fact is while I've been speaking, your fingernails have grown longer than the metal is thick on our bags. So if you look at your fingernails and you turn away, that's 1 angstrom. The metallized film is about 100 angstroms thick. So it's very, very thin, and so, but it does a big job associated with that. And we use very thin films to do this. And flexible packaging is one of the most efficient ways in terms of grams of packaging per gram of product that you can have, but we have a lot of challenges with end of life because we don't have a good space for it from a recyclability standpoint. But if it goes to landfill, it's still a very small amount of material there. So we're working on reducing, so we're constantly working on having less headspace in the bag, and number 1 complaint from everybody is there's too much air in my bag, and I guarantee you within a half a gram of what's printed on the bag, that's what's in the bag. But there's product settling and other things. So we've invented some new technology where the chips fall faster into the bag, more as a unit, and so we can actually make our bags smaller and use less material, and anytime you lose less material, that's certainly sustainable, but more than anything, it's for productivity and economically advantage. And then recyclable, we'll talk about, we just had some LinkedIn announcements from our Chief Sustainability Officer on some things we're doing in Europe with recycled polypropylene in our films. And then we have our biodegradable films that those of you who are closer to my age or at least been around for a while, you remember the Sun Chips bag from 2009 that was very noisy, and we got lots of complaints and lots of questions on did we know it was that loud, and it's like, yes, we knew it was that loud. But our CEO at the time said, I know that's going to be an issue, but we're going to do it anyway because it's the right thing to do to get started. And so I really admired him for pressing forward and so forth. And then we took it off the market. But why did we take it off the market? Because it was too loud? No. It just didn't do anything for the brand. It was a little bit ahead of its time, and it just didn't do anything to grow the brand. The other learning that I would share always from a business case standpoint is we talked about the packaging and stopped talking about the products. As the packaging guy, I think that's the most important thing. but apparently the product inside is why you buy it. But it's the first moment of truth and the last moment of truth, and that's the challenge in this space is it looks good on shelf, it's great, and then you're left holding the bag when you're done, and what do you do with it? And that's what we have to figure out as a society, as an industry, and do more things with it. We're also working on paper-based packaging within our portfolio. Quaker oatmeals are in paper sachets, but how do we make them recyclable? And I won't spend a lot of time talking about paper-based stuff today, but it's a really growing space, and especially in this industry, has possibilities. But there was a reason we were in plastic and not paper, because those, in order to make paper recyclable, we have to make it a lot thicker and keep the plastic about the same to recover those fibers. And when I was a kid, we were running out of trees. Apparently we found a bunch of trees, and now everybody's trying to convert to paper. So, and sustainable forestry and all that stuff's really important, but paper has its limitations, but it's also, people understand what they could do with it. What they will do with it is different, but that's part of the challenge of paper-based solutions. And so we've talked a lot about collaboration and so forth, and in this area of sustainability, the reason I kind of do this spiel all over the world is it takes a village to do this. And with this is all pre-competitive. Sustainability is the right thing for the planet. So this isn't about PepsiCo creating a competitive advantage in this space and keeping it close to the best. We want to share this with everybody, and that's why I'm out here advocating for it, and we'll show you how you can get involved, and we'll teach you how to do stuff. But these partnerships around sustainability are uber critical to really drive success. And we all know one of the biggest challenges we have is at the consumer point and no collection opportunities in your municipalities for flexible packaging. The other challenge, and this was proven in the Material Recovery for the Future project that was a few years ago up in Philadelphia with a MRF there, is you have to have closed bins. If you're going to start putting flexible packaging in, you need to have closed containers for the recycle bins, otherwise the flexible packaging blows out. And that's really the biggest issue we have as an industry of flexible packaging, and I was with the Flexible Packaging Association talking about similar things where because we're lightweight, we can blow out. And specifically in snack foods, and when you eat it away from home and you're at the park, at the beach, what kind of trash systems do we have? We have open barrels, and people, I believe it's not people throwing it out of the back of their pickup truck, it just blows out naturally because we don't have good collection systems associated with that. So that needs to evolve and change as a society. And then more sortation is needed, and then we'll talk about different end-of-lives associated with that. But so with this area of recycling, you all see these kind of circular economy. One of the interesting things about flexible packaging and plastic packaging as a whole is there's a lot of legislation we'll touch on in a moment, but we hold packaging and plastic really to a higher standard right now than we hold anything else. So paper, we think it's good. We can use our corrugate boxes and Amazon mailers and things that you can, you know that fiber is getting recovered, but you don't care where that fiber goes. You don't think that box becomes a box and stays a box each time around the horn. Aluminum cans are that way. I'm always fascinated being here in California to see aluminum cans of water instead of plastic bottles. Well, why do we have that? Well, because people think it's way more recyclable, and it is. It's way higher greenhouse gas footprint than the alternatives, but it's more recyclable because of that. But we don't expect that aluminum can to stay an aluminum can. It can be aluminum wire or go into car parts and so forth. But plastics, we expect it to go bag to bag or bottle to bottle, and we have to draw bigger circles around this stuff to really make this more effective in the future. And especially because flexible packaging is going to be very challenged, and multi-layer plastics, all the MLP bans and things, is going to be very challenged to mechanically recycle. The things that flexible films like stretch films can be recycled very easily because they don't have any printing on it, but all of our stuff needs to communicate to the consumer, and with that ink, it ends up being downcycled if it gets mechanically recycled. There's new solutions for de-inking, and those things are coming, but they're a long ways away in our municipal recovery facilities. So advanced recycling is where we believe the right thing to do for flexible packaging is to have that space there. And so advanced recycling is a funny term. It really is just different chemical processes by which we take that material and turn it back into a feedstock for either the petroleum industry to make new polymers or other alternatives. But you'll see things like pyrolysis is the word that we're using more than anything now, and that's going to evolve. Basically, that turns it into a feedstock that'll go to a petrochemical facility and go back into a polymer. That's going to be fed at very small percentages into the feedstocks, but it'll be that way. And then when we use what, in our case, we'd call it RPP, advanced recycled polypropylene, is that it would be, basically it's a mass balance system. So think about it like credit systems. So like if you buy wind energy for your house, you're not buying the wind, you're buying a credit system that goes at. And in advanced recycling, that's what we'll do to be able to make that happen. There's other systems like dissolution that on this chart, they don't consider it chemical recycling, but what dissolution is you're taking the polymers, you're dissolving it in solvents like paraxylene and other exotic chemicals, but suddenly that's a physical process, not a chemical process. But these things are all evolving, and we don't know which is going to work best, but we think the next logical step is probably pyrolysis. And so in this process, one of our biggest challenges as an industry is we're relying on our material recovery facilities, MRFs, to do the job that we need them to sort the materials. The MRFs of today were designed in the 80s for a lot of for corrugate and paperboard, and they're really good at that. And they really don't handle plastics very well. And so with that material recovery for the future project, the industry put in $1 million into that facility to be able to do flexible packaging. And so that's probably what is needed, is about $1 million investment in every MRF. Well, how many MRFs are there in the US? 900. So that's a lot of money that would have to happen, and you'd be investing in old technologies and trying to get it up to speed. And so this is my personal hat, not my PepsiCo hat. I think that's a long shot. That's going to be very hard to do. The new things that are starting to come out, and Freepoint is one of the ones investing in this, is we think sortation will happen at the municipal solid waste facilities instead. So instead of you figuring out how to sort your trash and trying to find the right bin to put your stuff in, it'll all go in the trash, and it'll go to a municipal solid waste system, and you'll sort there. And there's a lot of people investing in that technology because there's a lot of materials that are going to landfill that have value. So all kinds of metals and other things that end up in the landfill, they can sort out and actually make money at it that way. I personally believe that's the better solution, because trying to teach the 8 billion people on the planet to change their behavior is daunting. So and PET, we've certainly in my whole adult life, we've been recycling polyester bottles, but how much do we get back? And what is the PET recycling rate in the US? It's less than 20%, and we've been doing that forever. And so flexible packaging, do we really think it's going to get to way beyond that in a very short period of time is unlikely. And so it's not that it's not going to happen. So there's things like store take back program where you can take your grocery bags back to the store. That's a great thing, but I don't take my trash back to the grocery store. And really, when you look at the statistics, it's less than 4% of the people doing that. And so while you can claim that, the question is it greenwashing and so forth, because is it really being done at scale? And that's where all of our metrics are. It's not about that it's designed for recycling, it's also is it being at practice and at scale, and that's a very daunting thing. On that last part, we'll talk about why we think biodegradable packaging, and I'm going to use the word biodegradable, but I will define it. We can't legally use that term on packaging because you have to define the conditions by which you do that, otherwise that's greenwashing. but we'll talk about why we think it has multiple end of lives, and it's really an important thing to think about, that it can go in a lot of different places. So we'll talk about PHA, and we'll teach you a little bit of chemistry today. Polyhydroxyalkanoate is a new polymer that didn't exist. Well, it's existed for a long time because it's in your human body too, but it's made from bacteria, and it's a polymer that has, I think, what we've proven over the last few years, it has the range to be like polyethylene, anywhere from an elastomeric, soft stretching material to a crystalline material. And so it's very early stages, but it has a lot of merit, and it's something we're investigating a lot. And with that, we've made a home compostable structure. So back in the Sunchip days, that was industrial compostable. And one of the pushbacks, and it's absolutely a fair one, is but nobody industrial composts, or very little is industrial composted, and that's right. We didn't design this structure with composting in mind. We designed it so it would degrade if it ends up inadvertently in the environment and degrade as litter. Now we can make a claim of home compostability, and that's important for certification and things, but that's not our intention. California is going to start mandating food waste diverted from landfill. Food waste, like our bags could go with food waste, and that would be great, but they don't really want our stuff because there's too much risk of contamination of other plastics getting in there, so they're really focused on food waste, but food waste will end up going to anaerobic digestion. That's how wastewater treatment facilities work, that sort of stuff, but that is a viable option. But one of the things my team and that I'm in charge of is really we've created a supply chain to be able to produce these materials, from the polymer to the film to the converting to running on our own equipment at the same speeds and no issues. So we've done that successfully, that it's at the start. It's not perfect yet, but we'll continue to advance it. We're spending a lot of money on biaxially oriented films. So what we make, if you're not familiar with packaging, but we make the films that we use are made on the scale of about a football field. It's 1 meter wide at the front and 10 meters wide on the back end, and these big giant assets to be able to do the scale that we need as an industry. But these polymers have never done that. So in the past, a film company would learn how to do that with the polymer company and figure out how to do these things and make films out of it. In our case, we've invested that money because we're the only ones who want the film, and it's very nascent in this space. So with that, we've spent a lot of money and time trying to get that to work. So my team was actually, last week, was in Germany at our equipment manufacturer, Bruckner, and we had all our film suppliers present, all the resin companies present, and everybody practicing with each other to figure out how to make these films. And it's really exciting because we're making very big breakthroughs in a very short period of time, that those films will be available soon associated with that. And then I'll talk a little bit about our greenhouse in a moment. But so here's kind of where we're at with our development process, and we're kind of in this middle of the phase of working on certification. The certification process for these materials takes a year, so you have to demonstrate for home compostability that it disintegrates within 6 months and then fully biodegrades within a year, within 12 months. And so that biodegradation is that it's completely turning into CO2, water, and biomass. There's no microplastics, and I'll show you a slide that helped prove that, but it's basically completely converting into CO2, water, and biomass. But one of the problems is that takes a year. Well, I just made a new film that is better than yesterday's film. Start that clock all over again. Now I gotta wait another year to do that. So one of our dilemmas and maybe potential possibilities is maybe we don't make those claims because we need to get it better first, then come back and make claims about it, but make it blind pilots to start with. We'll see where we go. So this is a little bit about some of the suppliers we use, and I think if these slides are available, you can certainly take pictures, but you can call me. I'll tell you who we're using for everything we're doing. I'll make introductions to you to any of the polymer companies. I think of me and my team as ambassadors for this industry, so we'll help anybody get started in this space. And we've got a lot of great partners we saw that structure before. This is basically the same thing, doing that in different layers and different supplier partners that we have. And this slide is really the kind of our important slide we share with both internally and externally. Is the big deal with these new films that we're making is we feel like they have a variety of end of lives, and we're proving that as we're not just making this up, we're actually doing the demonstrations of it. So it could be home composted. If it goes to industrial composting, it goes really fast. PHA materials, one of the great things about, we have a greenhouse I'll show a picture of in a second, but we have a facility where we do on-site composting, both industrial conditions and home composting conditions. And we brought our CEO in when we first opened the center, and we had a PHA film. It was 100% PHA, and it was already starting to disintegrate within 10 days. And so they go very rapidly. I'll pause for a second, because if you worry about shelf life, well, what's going to happen in my pantry if these things degrade like that? If your pantry has the bacteria that it takes to do that, like that's in the soil, then I'm not going to eat at your house. But it is very shelf stable. The films are totally fine. It's just the issue is it needs to be in contact with bacteria, which is naturally occurring in the soil and the marine life and all kinds of stuff. But the big deal that we're trying to help people understand now is, because we think advanced recycling is the next logical step. It's not the end goal in 50 years from now, but it's the next logical step that'll happen, that will collect plastic, flexible packaging. Rigid packaging is more monolayer and could be mechanically recycled, but flexible packaging that has ink and all kinds of different types of layers and different polymers in it, chances are it'll go to advanced recycling facilities. Those facilities can do that with our plastics as well. So we can, the future state we're picturing in a few years when you have curbside collection, the biodegradable films can go in that same bin. And they'll go, and they're not as efficient as polyolefins in the process, but they're not detrimental. And the big deal with that is then they have a place to go and try to get it diverted from landfill. If it ends up in landfill, which it shows here, it is biodegradable just like food is. In a landfill, you have anaerobic and aerobic conditions, but in terms of the amount of plastic packaging versus food waste is less than a fraction of a %. And so it's not great, but it's not bad either, because as we divert food waste, we'll figure out these things as well. And then the big deal is if it leaks into the environment, chances are it's going to eventually end up in a waterway and in the ocean, and that's where these things will go away. Always the question I get is how fast? Well, it's not never, which is what today's packaging is, and instead it's probably a few years. But like I said, that's not fast enough for people, but it's better than never, which is what the reason we have, I'll pause for a second on that topic, is the reason we have extended producer responsibility taxes coming, the reason these things are issues is because of plastic pollution. The industry and we as a whole are talking about recycling. We're gonna pay EPR fees, we're gonna build recycling centers and so forth. Recycling doesn't address plastic pollution. There's a statistic said that 5% of all plastics made end up in the environment. If you know the size of the polyolefin industry, if you don't, we produce 160 billion pounds of polyethylene, polypropylene. That's growing at a rate of more than 4% per year. In 10 years, by the time we get all this infrastructure in place, 5% of that number is huge. And meanwhile, we haven't fixed the problem of plastic pollution. So we have to start on this journey with biodegradable films to start changing the direction and where we end up, change our trajectory associated with that. And because our polypropylene films today and our packaging films are recyclable, but they would be downcycled in today's time. You'd see Trex board, if everybody's got a plastic decking, that's where most of this material goes to now. But in the future state, we think more advanced recyclings will pick up. And those are all needed things, but they don't address that plastic pollution challenge. So this is a picture of the greenhouse I mentioned. It's been a huge boon for us because it allows us to test samples faster. To be able to do these certification studies, it's $40,000 and takes a year. So with this, we can test our individual films and do a lot of rapid prototyping, and so we're able to share that data and publish that data. We can't certify based on that. That's got to be a third party. we're a big, giant, evil corporation, so no one would trust us. So that has to be done by third parties to have validity, and it certainly does. And so to show you a picture of what this testing is we take a little paper square and put a piece of film in it, and then we put that in a mesh bag and stick it in the compost pile. And then you check it every so often to see how it's behaving. And this is an example of the print film that we have was gone in 62 days. And then our metallized barrier film was 100 days. So this is in the compost conditions, but it's home composting conditions. And that GHLC is our Greenhouse Learning Center, fancy title for a big glass house that has dirt in it, and a lot of bugs. But this is the example of it does disintegrate and in the period of time we need. And then the question of microplastics come into play. You have to prove that it gets completely converted to CO2, water, and biomass. So the shapes of these curves, depending on which films we're using, you do it versus a cellulose control, cellulose in this case paper, craft paper kind of things. You prove that it does completely convert into CO2, water, and biomass. So that's a big part of it, and that's the message I give you is that there's a lot of concerns over microplastics. Rightfully so. The example I always give is how many tires have you gone through in your lifetime? Where did all that rubber go that you had to replace your tire? It's still there, and it abrades. Every time you walk on carpet and you kick up stuff. My boss and I are working on a dust theory that like everywhere you go, there's these particles of dust, and we're making more and more of these things. We got to be concerned about them eventually. And whether it's real or not, it won't matter, because if you look at PFAS, and this industry I'm sure had to deal with a lot of PFAS issues related to paperboard and things, coated paperboard. Regardless of how you felt about it, it's banned. And so now it's gone and we can't use it. And so microplastics, if that becomes on Prop 65 and becomes a thing, then how are we going to get products to market? We got to figure those things out, and we got to get started. We have to start communicating what we're doing in these spaces. So a couple of quick things. Our structure is complicated and so forth, but what happens to the aluminum? Is that okay if it goes to the soil? Well, it's super thin, we talked about. It goes to aluminum oxide, and that's what we mine aluminum from the ground is aluminum oxide, and then convert that. The inks, we had to change all our inks to be non-ecotoxic. So the inks that we use today, we use extended gamut printing, 4 or 7 colors, and that makes the color gamut. Those inks, you can't, like green has copper in it, and blue has cobalt in it. Those had to be changed. So the Evolution Sun Chemical did a great job with us. If you think of Cool Ranch blue on a Doritos bag, that blue had to be changed, and the first stuff we printed without cobalt was teal, and so then little by little they reformulated, and now we have our Cool Ranch blue or sour cream and onion green. Those were hard colors to hit, but all these things you have to prove and demonstrate that they're okay. So in kind of conclusion to this part is like we've made a lot of progress to this, and the big thing, part of the reason I'm out preaching this and on a soapbox, so to speak, is because we want to make this available to everybody. So we have a lot of patents in this space that we've developed over time. We got those patents just so we could have right to practice, not that we could keep it close to the vest and not share it with anybody, so that we're licensing our technology to our converting partners. We're licensing it to the resin companies. So if you want to try these things, we'll tell you who to call, and you can get samples of film and run it on your equipment and see how things work. If you want introductions to anybody, we'll do that. It's self-serving. If I can grow the industry, I can drive cost out quicker, but at the same time, it's also the right thing to do. And I'm very passionate about that space, so happy to help anybody. If you want me to talk to your organization, invite me on a Zoom call, I'll happy to do that. And we got to move as one. The one elephant in the room is it's expensive. This is not low cost at this stage because it's brand new. In fact, the polymers When I started working on this program, or kind of took it over from our advanced research, long-term research people, I didn't think it was possible. I thought it was a dumb idea, to be honest. But then, like during COVID, I started walking outside a lot more, and it was embarrassing to see plastic packaging so much in the environment when you're out in parks and beaches and things. And so we need to do something about it. And so we're trying to help drive that and get people to understand what we're doing there. So with that, I'll pause and say thank you for the time and take any questions.